Welcome to the 8th part of VCAA Specialist Maths 2021 exam papers. In this video, we will present exam paper 2, section B, question 1, which consists of 7 parts. Questions in part A and part B were answered well by most students. In part C, quite a number of students did not draw the middle branch of the graph due to the setting of the CAS graphic calculator. Most students left part D unanswered.
Hello, Math Champions! I'm Dr. Chen. If you want to improve your math skills and understanding so that you gain confidence, enjoy math more, and get better results, click subscribe and hit the notification button so that you don't miss anything.
Welcome to this VCAA Specialist Maths exam paper series. This is section B of 2021 exam 2 paper. There are total 6 extended response questions in section B. In this video, we will present the first question in section B. As it can be seen, there is a function f of x in question 1, which equals the ratio of the product of 2x minus 3, or in parentheses, and x plus 5, or in parentheses, to the product of x minus 1, or in parentheses, and x plus 2, or in parentheses. There are 4 parts in this question. Part A is to express f of x in the form of a plus the algebra fraction bx plus c, or over the product of x minus 1, or in parentheses, and x plus 2, or in parentheses, where a, b, and c are real constants. Part B is to state the equations of the asymptotes of the graph f of x. Part C is to sketch the graph of f of x on the given set of axes. Label the asymptotes with their equations and label the maximum turning point and the point of inflation with their coordinates. Label the intercepts with the coordinate axes. In part D, a parameter k is added to function f of x. The new function g sub k of x equals the ratio of the product 2x minus 3 and x plus 5 to the product of x minus k and x plus 2, where k is a real constant. Accordingly, there are 2 sections in part D. Section 1 is to find values of k such that the g sub k of x has 2 asymptotes. Section 2 is to find values of k such that the graph of g sub k of x has no stationary points, given that g sub k of x has more than 2 asymptotes. Now, let's come back to part A of this question. According to the linear factors at denominator of f of x, x minus 1 and x plus 2, the linear factors on the numerator can be written to 2 times x minus 1, or in parentheses minus 1, and x plus 2, or in parentheses plus 3. Then we expanded the numerator based on the linear factors x minus 1 and x plus 2. After being expanded and simplified, the function f of x equals 2 plus the algebraic fraction 5x minus 11, or over the product of x minus 1 and x plus 2. According to part A of the question, here a equals 2, b equals 5, and c equals negative 11. Now, we move ahead to solve part B of this question, which asks us the equations of asymptotes. According to the form expressed in part A, f of x equals 2 plus the algebra fraction 5x minus 11, or over the product of x minus 1 and x plus 2. We have the following equations of asymptotes: y equals 2, x equals 1, and x equals negative 2. Part C is to sketch the graph of f of x on the given set of axes. according to the rule of function with the help of a CAS graphic calculator. We sketch the graph as shown on the screen. In the meantime, we also labeled asymptotes with their equations, the intercepts with the coordinate axis, as well as the maximum turning point and the point of inflation with their coordinates as shown in the diagram. As for part D, g sub k of x equals the ratio of the product 2x minus 3 and x plus 5 to the product of x minus k and x plus 2. For section 1, when k equals 3 over 2, g sub k of x equals the ratio of the product of 2x minus 3 and x plus 5 to the product of x minus 3 over 2 and x plus 2, which is simplified to 2 plus 6 over the result of x plus 2. When k equals negative 5, g sub k of x equals the ratio of the product of 2x minus 3 and x plus 5 to the product of x plus 5 and x plus 2, which is simplified to 2 minus 1 over the sum of x plus 2. Here we continue to work on section 2 of part D. In order to find values of k such that the graph of g sub k of x has no stationary points, the differentiation of g sub k of x with respect to x is shown on the screen. After being simplified, it is equated to 0 so that the quadratic equation with k as its parameter is established, as it can be seen on the screen. The roots of the quadratic equation can be expressed using the quadratic formula. After being simplified, x equals 15 minus 4k plus or minus square root of the result of negative 42k squared minus 147k plus 315, or over the sum of 2k plus 3. Here we continue to work on section 2 of part D. According to the expression of the roots of the quadratic equation, we do the following analysis. Obviously, when 2k plus 3 equals 0, or negative 42k squared minus 147k plus 315 is less than 0, there will be no stationary point for the function g sub k of x. Solving the inequality, negative 42k squared minus 147k plus 315 is less than 0 gives that the k is less than negative 5 or greater than 3 over 2. Since k cannot be equal to negative 3 over 2, so when k equals negative 3 over 2, or k is less than negative 5, or k is greater than 3 over 2, the function g sub k of x has no stationary point.
If you enjoyed this video, please give it a thumbs up and subscribe to help me make more math content like this. I will see you in the next video.